Hello everyone, I am Shubhangi Kharche, Associate Professor, Electronics and Telecommunication Department of SIS Graduate School of Technology, Nerul, Navi Mumbai. Today I will be giving insights on IP address. As discussed earlier, Internet Protocol is the heart of the internetwork layer of TCP/IP protocol stack and is used for Internet communication. Now, why do you need an IP address? To answer this question, we will first of all answer simple questions like how do you identify a person? By his name. How do you communicate with a person? By email, by post, etc. And nowadays there are various means of communication. What is required for email communication? Email address. What is required for postal communication? Home address. Now, how is every process or application running on a machine identified? By its port number, which is 16-bit number represented in decimal form. Now, how do we identify a machine connected in a LAN? By its hardware address or physical address. On similar lines, when a computer or machine is connected in the internet, it should be uniquely identified by an address. Since Internet Protocol is used for communication, the address is called an IP address. Thus, what is an IP address? It is an address which uniquely identifies a machine connected in the internet. There are two popularly used versions of IP address, IP version 4 and IP version 6. Now, how are these addresses represented? IPv4 address is 32 bits and it is represented in binary format or dotted decimal format or hexadecimal format. Now, let us look at the examples of IP address. In binary format, the IPv4 address can be represented like this, 32 bits, 32 binary bits. Now, let us convert these 32 binary bits to decimal format. For converting the binary bits to decimal format, you should know the binary weights of 8 bits in each octet. Now, when the bit position is 0th position, the weight is 1, and when bit position is 7th position, the weight is 128. So, for this binary address, let us now try to find out the decimal format. 11000000. Here 2 raised to 7 plus 2 raised to 6 is 192. So this first octet value corresponds to 192 decimal. Second octet value corresponds to 2 raised to 2, that is 4. Third octet value corresponds to 2 raised to 1, that is 2. And fourth octet value corresponds to 2 raised to 0, that is 1. Thus this binary form of IP address in dotted decimal format is 192.4.2.1. Now similarly, we can convert the binary form of IP address to hexadecimal format. The first octet value has 8 bits. So first 4 bits are 1100, which corresponds to hexadecimal number C. Second 4 bits correspond to 0 hexadecimal. Second octet value is 0, 4 in hexadecimal. Third octet value is 0, 2 in hexadecimal. And the last octet value is 0, 1 in hexadecimal. Thus, IPv4 address can be represented in binary format, dotted decimal format, and hexadecimal format. Now, these IPv4 addresses belong to classful addressing. There are 5 different classes of IPv4 addresses: class A, class B, class C, class D, and class E. And as there are 32 bits in IPv4 address, the total number of addresses possible with IPv4 addressing are nearly 4 billion addresses. Class A reserves one prefix bit for its identification. So, the number of addresses available in class A are 2 raised to 31, which occupies 50% of the total available address space. Class B reserves two prefix bits for its identification. So remaining 30 bits can be used for class B addressing. So 2 raised to 30 addresses are available in class B range, which forms 25% of the total available address space. Class C reserves prefix 3 bits for its identification. So remaining 29 bits can be used for addressing in class C. So class C occupies 12.5% of the total address space. Class D reserves 4 prefix bits for its identification. So remaining 28 bits can be used for addressing in class D, and thus it occupies 6.25% address space in the total address space. And finally class E also reserves 4 prefix bits for its identification. So remaining 28 bits can be used for addressing in class E. Class E also thus occupies 6.25% address space from the total available address space. Now, just to recall, an internet address is made of 4 bytes, which is 32 bits, that define a host connection to a internet. In other words, it uniquely identifies a machine connected in the internet. Every machine which seeks internet communication has to have an IP address. Now, IP address has a two-level hierarchy. The first level has the network part and the second level has the host part. So network is identified by an identification and host is identified by an identification. The first few prefix bits in the from the network ID part are reserved for identifying the particular class of IP address. Now let us see what are the prefix bits for different class of IP addresses. In class A, there is only one prefix bit which is set to 0. So if the first bit of an IP address is 0, it means that it belongs to class A. If the first two bits of an IP address are 10, it belongs to class B. If the first three bits are 110, then the IP address belongs to class C. If the first 4 bits are 1110, then the IP address belongs to class D. And if the first 4 bits are set to 1, then the IP address belongs to class E. Now, as IP address has got 4 bytes, in class A, only 1 byte is forming the network ID part and remaining 3 bytes form the host ID part. So there are 8 bits in network ID part in class A and 24 bits in the host ID part. Now with this configuration, 2 raised to 8 networks are possible in class A and 2 raised to 24 hosts per network are possible in class A IP addressing. In class B, the network ID part has got 16 bits and the host ID part has got another 16 bits. So with this configuration, in class B, 2 raised to 16 networks are possible and 2 raised to 16 hosts per network are possible. In class C, 24 bits are there in the network ID part and remaining 8 bits in the host ID part. So with this configuration, 2 raised to 24 networks are possible in class C and 2 raised to 8 hosts per network are possible in class C. Now, if we try to compare class A, B and C addresses, then you will find that class A forms the larger size networks, class B forms the moderate size networks, and class C forms the smaller size networks. In class D, addresses are reserved for multicasting. And class E addresses are reserved for future use by the IETF, Internet Engineering Task Force, or they can be used for some research purpose. Now, let us try to understand the first octet values for each of the classful IP address ranges. So, class A has got the first octet value from 0 to 127. Class B has got first octet value from 128 to 191 in decimal. Class C has got first octet value from 192 to 223 in decimal, and class D has got first octet value from 224 to 239. Finally, class E has got first octet value from 240 to 255. The class D address is used as a group address while multicasting, and use of class E addresses is undefined. So class A range is from 0.0.0.0 to 127.255.255.255. Now from this range of IP addresses, some of the IP addresses are special IP addresses and some addresses are the private IP addresses and remaining are the public IP addresses. Private IP addresses are those which can be used in the private LAN. The range reserved for private IP addresses from class A is from 10.0.0.0 to 10.255.255. and the addresses belonging to 127.0.0.0 network are reserved for loopback testing. This testing one own TCP/IP stack operation. So 127.0.0.0 to 127.255.255.255, all these addresses are reserved for loopback testing from class A. So these addresses, special addresses, cannot be assigned to a machine connected in the internet. From class B range, again a set of IP addresses are reserved for private use in a LAN, and those IP addresses are 170.16.0.0 to 172.31.255. From class C, an IP address range reserved for private use is 192.168.0.0 to 192.168.255. Now let us see the IP address examples. Find the class of the following IP addresses. The first IP address is 212.34.52.16. Now, since the first octet value lies in the range of class C IP address, class C IP address range is from 192 to 223, first octet value. So, first IP address belongs to class C, second IP address has the first octet value as 238, which lies in the range of class D. So second IP address belongs to class D. The third IP address first octet value is 243, which lies in the range of class C IP address, which is from 240 to 255. So the third IP address belongs to class E. The fourth IP address has the first octet value as 129, which lies in the range of class B IP address range, that is from 128 to 191. So the fourth IP address belongs to class B. The fifth IP address has the first octet value as 22, which is within the range of class A IP address. So this IP address belongs to class A. The last IP address is having first octet value 100. You might be thinking that it is belonging to class A, but you need to check carefully whether each octet value is a valid value or not. Here the third octet value is exceeding the maximum possible decimal value for 8-bit binary number, that is 255. Thus, this last IP address is not a valid IP address. Now let us find the class of the following IP addresses. In first example, the first octet value is 11000000. Since the first, so let us now convert these binary values to decimal. This will be 2 raised to 7 plus 2 raised to 6, that is 128 plus 64. The decimal value is 192, and as 192 lies in the range of class C, this IP address belongs to class C range. Other way to find out the IP class is from the prefix bits. The first three prefix bits are 110, which is the identification for the class C IP address. Thus, the first given IP address belongs to class C range. The second IP address has prefix bits 1110. Thus, this prefix bits belongs to class D. Thus, the second IP address is the class D IP address. Now, we can verify it by checking the decimal value. 2 raised to 7 is 128. 128 plus 2 raised to 6, 64. That is 192. 192 plus 2 raised to 532. 192 plus 32 is 224. So this third example belongs to the class D IP address range. Second example belongs to the class D IP address range. The third example has a prefix bit as 0. The IP address belongs to class A. The fourth example has 4 prefix bits as 1111. So this IP address belongs to class E. The fifth IP address example has the prefix bits 10. It belongs to class B. Now this diagram shows a network with 2 levels of hierarchy. In internet, the IP addresses are having 2-level hierarchy, the network and the hosts. The network will have a separate IP address, and the host belonging to that network will have the unique IP addresses belonging to that network. So here the network has got the IP address 141.14.0.0 belonging to class B, and the machines connected to this network will have the same network ID 141.14, but the host ID is differing 2.105, 2.21 to 7.96 and so on. Now, what are the problems with classful addressing? Even though an organization is not requiring the IP address range of class A, it is requiring very few IP addresses, let's say 512, and if class A IP address is assigned to such an organization, then remaining, then 2 raised to 24 minus 512, these many IP addresses will go waste. Similarly, Similarly, if an organization is requiring only 100 addresses and it is allocated class B IP address, then it will uh, utilize only 100 IP addresses from the available 2 to 16 addresses, and so remaining addresses will go waste. So this was the drawback of the classful IP addressing. To remove this drawback, the IP addresses were subnetted to make subnetted. With this subnetting concept, the IP address, the two-level hierarchical address now becomes a three-level hierarchical address. The subnetted IP address will have network ID, subnet ID, and host ID. Here, the subnet is a small network. From a large network, smaller networks are formed. Now the IP address assignment is done in smaller networks, so the IP addresses are used efficiently with subnetting. So with addresses with and without subnetting, so this is an example of an IP address without subnetting having a network ID part and a host ID part, and this with subnetting, the IP address will have the network ID part, subnet ID part, and the host ID part. So network with three levels of hierarchy is shown here. This is the entire network. This site has got an IP address 141.14.0.0. In this, under this site, there are sub networks 141.14.2.0, 7.0, and 22.0. Now each of these sub network is having a number of hosts connected to it. So this becomes the three levels of hierarchy. With the use of subnetting, the IP addresses were used efficiently. In next video lecture, we are going to see the example, what is subnetting, what are its advantages, and examples on subnetting. Thank you.